Hello, my name is Dr. K. Joseph Kanicki. I'm your instructor for MGF 2107. Applications of mathematics. This is the first video. We're going to cover basic ideas of the metric system, a couple of conversions, a couple of methods to finish your quiz number 1, which I'll remind you is due a week from today, or actually next Friday, April 10th by noon. Please scan it, email it to me at Keiser University email. I've already emailed you formula sheet number 1, which covers quizzes 1 and 2. And I've also sent you quiz number 1. 4 pages, which you are to complete once again by next Friday. So, the metric system. It's an international system used around the world, and it's based on the powers of 10. So it's a decimal system. Just like money has differences across countries, so do certain measurements. Like in America, we use 12 inches per foot, 3 feet per 1 yard, 5,280 feet per mile. We don't use a decimal system, but for medicine, for industry, manufacturing, to be consistent with the rest of the world, we do use the decimal or the metric system. And you can see the metric measurements on containers that you buy, whether it's liquid containers or cereal for weight or whatever. Distances, you'll see distances measured in both systems. So if you look at your formula sheet in the very middle at 10 to the 0, it says unit. So there's 3 basic units. One is for distance. And we used the meter, abbreviated lowercase m. M will also be a prefix, but when the letter stands alone, it's meters. The second is volume. And it's measured in liters. Most books, or a lot of books, use a lowercase l. I use a capital L. That way there's no confusion. Liter, always the same. And the last one is, internationally it's called mass. We call it weight. Little g for gram. Now, grams are what we measure small amounts, medicinal amounts, anything small. When we use industrial type measurements, we use kilograms, which is our first prefix. kg. So the K is for kilo, the G is for gram. It means 1,000 grams, because kilo means 10 to the third. Ten to the third times gram. But 10 to the third is 10 times 10 times 10 is 1,000. So 1 kilogram equals 1,000 grams. Then this affords us the intro, a mechanism to talk about what we call unit fractions. Now, since a kilogram and 1,000 grams are equal, if I divide one by the other, I get a unit. Since they're equal, when you divide 2 equal things, you get 1, the unit. But I can divide them the other way, too. So both of these fractions on the left and the right are what we call unit fractions. And that's how we're going to be able to manipulate and change designations. Also, later on, we're going to go from the American system, the so-called American system, to the metric system, or vice versa. We're going to use unit fractions. But within the metric system, there are always powers of 10. And there's a couple of ways to do this. So I'm going to erase this real quick. Stand by. Suppose I wanted to change 21.5 kilometers to meters. So that's the question. How do I change 21.5 kilometers to meters? Well, this one's straight up. You could just change the K to 1,000. And you have it, 21.5 times 1,000 is 21,500. So it's a straightforward substitution for what K is. K is 1,000. And I multiply it times the number in front, and kilometers is 1,000 meters, so I'm just making a direct substitution. Now, we could use the unit fraction method if you want to use it that way. Here's how you would do it. You would multiply by the unit fraction, which allows you to cancel kilometers. So that means kilometers would have to go in the denominator. So this is a unit fraction, as we described earlier. This is equal to 1. And when you multiply anything by 1, you don't change its value. You change what it looks like. So the kilometers cancel, and I have 1 in the denominator, and I have 21.5 times 1,000 meters. So, another method, same answer. By the way, if you haven't figured this out, I'm in my driveway, and in the background you can hear my flag clanging on the pole. In the next video, I'll remove the flag so you don't get that background noise. Okay, let's do another one. Suppose we wanted to change. By the way, the other way to look at this is if you look in the sheet. If I go from meters to kilometers, I'm sorry. If I go from kilometers to meters, because we started on the left with kilometers, K is up here and M is down here. It's one of the units. You can see G, M, or L. That's 3 spaces. That's 10 cubed. It means multiply. This is an old one. Got to change that. When you go up, you multiply. When you go up, you divide. When you go down, you multiply. So it means multiply by 1,000. There's a typo on these. I apologize. But yours at home says divide, and down here it says multiply. I should probably change that. So this one is divide, and this one is multiply. Somehow whoever typed it up did it incorrectly. I guess I'll have to take the blame for it. Anyway, we went down, so we multiplied. We went down 3 spaces, that's 10 to the third, so we multiplied by 1,000. So there's 3 different ways. You can make the direct substitution, you can use the unit fraction, or you can just traverse your way up and down the scale and do the correct operation. See, up here it says going down you multiply, going up you divide. So it's backwards from what it says here, but if you read B and C, they're correct. Okay? So let's do another one. Suppose we wanted to do 221 decigrams. So it's lowercase d. Lowercase d is deci, uppercase D would be deca. So one's below and one's above, but their power is a 10. So we want to change 221 decigrams to kilograms. So let's use the table. So if you find the D and you go up to kilo, you go up 1, 2, 3, 4. So we would move the decimal place, we would divide by 10 to the 4th. So we move the decimal place from where it is, and we would need another decimal or another place there, another placeholder. So we would be dividing by 10,000, 10 to the 4th. To use the unit fractions, I would do it this way. I would put decigrams in the denominator and kilograms in the numerator, and I would know that to go from decigrams to kilograms, there's 10,000. See, this is the smaller dimension. This is the larger, so there's more smaller ones than there are larger ones. So it's dividing by 10,000, which means move the decimal place 4 places to the left. Okay? Let me erase this, and I'll be right back. Okay, let's do another one with volume. Let's do we can do deciliters again. We'll go the other direction. 936 deciliters equals how many milliliters? So if we do the table, if I find D and I want to find M, from D to M is go down 2 spaces, so we're going to multiply by 100, which means we got to add 2 zeros because the decimal place is right here. And when we multiply, we move the decimal place to the right. So the answer will be 93600. So the other way to look at it is, let's do the unit fraction. So I'm going to put deciliters in the denominator. I just have to figure out how many deciliters or how many milliliters. Well, going from milliliters to deciliters, or vice versa, there's 100. Right? See, to go from D to M, multiply by 100. So the deciliters cancel, and we get our 93,600 milliliters. Okay. So that's it for unit fractions. The one more topic we want to discuss for quiz number 1 to help you out will be temperature. So in everyday use, we use Fahrenheit temperatures. We all know that 32 degrees freezing, 212 degrees boiling point. 100 degrees is hot when you're outside. 90 degrees is hot for that matter. But what's basically going on is we have a thermometer. A thermometer is an evacuated glass tube with mercury in the bottom in a little bowl like this. And the mercury rises with heat because the temperature changes to pressure, Boyle's law, whatever. When it gets to when it's at freezing, on the Fahrenheit we call this 32 degrees Fahrenheit. Well, on the Celsius we call it 0 degrees Celsius. They're equivalent, just different scales. In other words, when the thermometer reaches that level in a freezing ice water bucket, you mark the line. Well, this is called 32 degrees Fahrenheit on one scale. It's called 0 degrees Celsius. And Celsius used to be called centigrade. And centigrade means 100 grades. 100 dashes, 100 grades. See centi? 100. So the reason for that is because if the mercury in the tube rises to boiling point, if it goes all the way up to boiling point, then that's 100 degrees Celsius. See, 100 degrees between freezing and boiling on water. Well, in the Fahrenheit system, we call that 212 degrees because there's 200. Well, there's 180 ticks between here and here. That's just the way it was set up. It's not a true zero, in other words. There is no true zero on temperature, at least not for these two scales. So if you remember from the linear equations, when you took algebra, we can find the slope because we have 2 points. If we call this x and this y, for instance, so x equals c and y equals f. And you remember the formula. The formula was y equals mx plus b. So m, the slope, is m. It equals the difference in the y's divided by the difference in the x's. And so the slope is 212 minus 32 over 100 minus 0. So the slope is 180 over 100, which is 9 over 5, because it's times 20, which cancels, right? 9 times 20 is 180, 5 times 20 is 100. They cancel, so that's the slope. So I know the slope, and I picked two values. Let's pick these two, because I got a 0 there. So what we're saying is that, so y equals 9/5 x plus b. I'm going to choose this for my y, this for my y, and this for my x. And you can see b is 32, because this is 0. So we have y, but y is really f. And x is really c, and b was the intercept is 32. So if you look on your formula sheet, on the second page, I believe, yes, temperature. I've given you the freezing point, boiling point equivalences, and then you can see F equals 9/5 C plus 32. So if I know the Celsius temperature, I can find the Fahrenheit, but I can also solve this for C. Algebraically, if I subtract 32 from both sides, and then I multiply both sides by 5 over 9, I got to use parentheses on this side, this cancels, and I get C equals 5 over 9 times the quantity F minus 32. So this is the second formula for temperature, and it gives me the Celsius temperature if I know the Fahrenheit temperature. So all we're doing is equating the two scales because they're linearly related. It's a linear relationship. The slope is constant. The rate of change is 9 over 5. So once we know that, and we have 2 points, we can form the equations. So that's where they come from. Okay? So using them is fairly straightforward. Once again, let me erase. So, for instance, suppose I wanted to find out the temperature let's say It's 92 degrees. Let's say it's 92 degrees here in southwest Florida. Now, if you're driving by a bank, the bank's going to flip the two temperatures, and you're going to know right away. We'll just go to the nearest tenth of a degree either direction. So I want to know what the temperature is Celsius. So if I have Fahrenheit, then I use this formula. So Celsius is equal to 5/9. I plug in 92 minus 32. So I know the Fahrenheit, I don't know the Celsius. So this is 5/9 of 60. And if I work that out, I'm pretty sure that I thought I had better notes. Oh well, I don't have my notes, but let's just do it longhand. What the heck? So this will be 300 over 90, right? 5 times 60 is 300, and if I use the long division, look at that, I get it. It's a repeating decimal. So 33.3. So it's approximately 33.3 degrees Celsius to one decimal place. So 600 or 300 divided by 9 is 33.33333. So it's a repeating decimal. I lucked out. Let's go the other direction. Let's say we're driving, or we're driving up in up north, and we look at the bank and it says minus 23.9 degrees Celsius. And you go, oh, that's awful cold. I wonder what it is Fahrenheit. So Fahrenheit, we use this formula. We got 9/5 of minus 23.9 plus 32. And if we work that out, we get minus 11.0 degrees Fahrenheit. So you just use whichever formula that you don't, whichever one you're given, you use that formula. So if you're given C, you use this formula. If you're given F, you use this formula because you want to solve for the other one. Oh, let's see. What else can I tell you about that? That's about it for temperature. If you have any questions about how to complete some of these problems as you go through quiz number 1, email me, text me, call me. You have a week. You should be getting this video. Let's see, it's Saturday, today's Saturday, so it's probably Sunday. You'll have a whole week to look at it. You can stop it, repeat it, etc. Best of luck. I'll look forward to seeing you on video number 2. Dr. K out.